going? I know I said we were going to continue inequalities tomorrow morning, and we will, but I still want you to watch the video for tonight because we're going to go straight from inequalities straight into this lesson tomorrow. However, what I want you to also be able to work on for me tonight if you can, and I don't think I have all the problems, do I? No, I don't. Okay, never mind. We will discuss that too. I might actually make that class work for you tomorrow instead. All right, so we've got an opening exercise. So we're on lesson 12. We finally get to some good stuff, what I love, the kind of stuff I love. All right, solving equations, okay? Now, you all have done some solving equations in 7th grade, some 1-2 step kind of stuff, maybe even more after that, I'm not sure. All right, so let's discuss solving equations, okay? Solving equations is the process in which we determine what the value of x would equal, okay? We are not given the solution of x. We have to determine what x would equal in terms of the problem that is given to us, okay? What value would make the equation true? Which value of x would say this is what x equals, this is what the equation equals, this is what's true? All right, so let's look at A, B, C, and D here. So it says answer the following questions. Why should the equations x minus 1 times x plus 3 equal 17 plus x, and x minus 1 times x plus 3 equals x plus 17 have the same solution set? Okay? Well, in order for us to have the same solution set, that means that these two equations have to have the same values in the same order, in the same placements. Okay? So let's look at this. Do I have an x minus 1? I have one here, and I have one here. Do I have it being multiplied by x plus 3 like I do here? Yes, I do. Do I have a 17 plus x? No, I have an x plus 17. But are those the same thing? Doesn't the commutative property of addition state that I can change the order of the add-ins without changing the value of the problem? It does. So 17 plus x and x plus 17 are identical to each other. So yes, they should. Okay? The terms are identical. Nothing has changed. So let's look at B. Why should the equations x minus 1 times x plus 3 equals 17 plus x, and x plus 3 times x minus 1 equals 17 plus x? Hold on, guys. Hello? Speaking. Yes, ma'am. Yes, ma'am. Ma'am, that's my goal. So enter in on Washington Avenue? Okay. Okay, I appreciate it. Thank you, ma'am. All right. Bye-bye. All right, guys, so it looks like I'm going to have to edit some stuff out, so I'll have to look into that real quick. All right, so let's get back to what we were supposed to be talking about before I got my phone call that interrupted everything. All right, so why should the equations x minus 1 times x plus 3 equals 17 plus x and x plus 3 times x minus 1 equals 17 plus x have the same solution sets? Okay, well, let's go over something here real quick, all right? So we got 17 plus x and 17 plus x. Those are identical. Now we've got x minus 1 times x plus 3, but here we have x plus 3 times x minus 1. Okay, these are in different places, but everything inside them is the same. X plus 3 is still there, x minus 1 is still there. Okay, so we need to sit here and make an assumption. Okay, according to the commutative property of multiplication, I can change the order of my factors, but my product would still remain the same. So according to the commutative property, this is still okay because the values are still the same. The factors are okay. So yes, the terms are still identical. So we're good there. Okay, so let's take a look at C. Do you think the equations x minus 1 times x plus 3 equals 17 plus x and x minus 1 times x plus 3 plus 500 equals 517 plus x should have the same solution set, and why? Okay, so we got x minus 3 times x plus 3 equals 17 plus x, and x minus 1 times x plus 3 plus 500 equals 517 plus x should have the same solution sets. Why? Okay, well, this does kind of make things a little interesting because we still have x minus 3 here and x minus 3 here. We still have x plus 3 here and we still have x plus 3 here. We still have x and we still have x. But we have a new term, 500. And we have 500 added to the other side. Has anything really been changed, though? Could I subtract the 500s from both sides and still get 17 plus x? Okay, yeah, I still could. Everything is still the same. I've got no problem here. The terms are still, okay, the same solution set. Because the equations are balanced. Mr. Hale, what do you mean by balanced? Well, I mean, they added 500 here and added 500 here. They balanced the equations. Nothing's really changed. We still have a solution that would still be identical because I could subtract out 500 here and subtract out 500 here and still get x minus 1 times x plus 3 and still get 17 plus x here. I can still get the same problems. So nothing's really changed. For D, do you think the equations x minus 3 times x plus 3 equals 17 plus x? You know what? I'm going to keep my mouth shut here. I want you to do D. I want you to do D tonight for homework. All right? And we will talk about it first thing tomorrow. All right? So let's go ahead and move on to the next one. All right? Well, actually, I guess I don't need to really do that. So we're going to exercise 1 next. Use the commutative property to write an equation that has the same solution set as x squared minus 3x plus 4 equals x plus 7 times x minus 12 times 5. Commutative property, huh? It's kind of a little good one there, doesn't it? Let's take a moment and take a look at that. I'm going to keep my mouth shut for a second here, and I want you to look at this problem, and I want you to tell me, or I want you to see if you can figure it out yourself for just a second. Okay, so it says it wants me to use the commutative property. Okay, so the commutative property states I just need to move some things around. Okay, so I can rewrite x squared minus 3x plus 4 and say it's a negative 3x plus x squared plus 4. And that would equal x minus 12 times 5 times x plus 7. I use the commutative property. Everything is still the same. Nothing's changed. All the terms are right. So I'm looking good. Okay. What about using the associative property to write an equation that has the same solution set as this? Well, I could sit there and say, okay, x squared minus 3x, put that in parentheses, plus 4 equals, x plus 7 in parentheses times x minus 12 parentheses, times 5. Okay, all I did was just change the groupings around. Okay, nothing's really changed. Okay, so does this reasoning apply to the distributive property as well? Yes, it does. Okay, I can use the distributive property to multiply out x minus 12 times 5 and change the value of the problem. I could still leave it as x squared minus 3x plus 4 equals, and then I use the distributive property. I take 5 and I multiply it by x plus 7. So now I get 5x plus 35, close parentheses, times x minus 12. Okay? That is still going to be equivalent because all I've done is just take the 5 and I distribute it to the x plus 7. Okay? So the distributive property in this reasoning can still apply to this type of problem. Nothing has changed there, okay? All right, continuing on. All right, so consider the equation x squared plus 1 equals 7 minus x. 7 minus x. Verify that this has the solution set of a negative 3, 2. Draw the solution set as a graph on the number line. We will later learn how to show that these happen to be the only solutions of this equation. All right, so I need to zoom in because we obviously have some work we got to do. All right, so we're looking at this equation. I want to verify that a negative 3 and 2 are the only solution sets. Okay? So I do that by substitution. Okay? I'm going to substitute wherever I see an x, I'm going to substitute in negative 3 and also a value of 2. But I'm going to do these 2 separate times. So the first one, I've got a negative 3 squared plus 1 should equal 7 minus a negative 3. Okay? And then this last one would be 2 squared plus 1 equals 7 minus 2. Okay, so now I got to verify. Well, a negative 3 squared is going to be 9 plus 1 equals 7 minus negatives turn into pluses, so that'd be 3. Then on the bottom one, I've got 2 squared, which is 4 plus 1 equals 7 minus 2. Well, 9 plus 1 is 10 equals 7 plus 3, which is 10. All right, 4 plus 1 equals 5, and 7 minus 2 equals 5. So it verifies. Those are the only 2 solution sets for a negative 3 and 2. Okay? So I'm not going to mess with that. That is good. I don't really care about the solution graph as the number line. There is no point for me to consider doing that, okay? Makes no sense. All right. So let's add 4 to both sides of the equation and consider the new equation. X squared plus 5 equals 11 minus x. Verify 2 and a negative 3 are still the solutions. So now they have added 4 to the original equation. Okay? They added 4 here and they added 4 here. Okay? That's the reason why we get x squared plus 5 and 11 minus x. So again, I got to verify x should equal a negative 3 and x equals 2. Okay? Now let's check it out. So I've got a negative 3 squared plus 5 equals 11 minus a negative 3. And then I've got 2 squared plus 5 equals 11 minus 2. Okay, let's check. Negative 3 squared is going to be still 9 plus 5 equals 11 minus negatives turned into plus 3. Down here at the bottom, I've got 2 squared, which is 4. Okay. Not sure why I'm not writing. Oh, you got to be kidding me. All right, guys, I'm going to take a pause here because for some reason my Active Inspire board is not working well for me today. All right, sorry, guys. Like I said, my board seemed to have messed up. Okay, so we still need to verify. We need to finish verifying that a negative 3 and x equals a negative 3 and x equals 2 are still verifiable solution sets for this problem. So a negative 3 squared plus 5 should equal 11 minus a negative 3. And then 2 squared plus 5 should equal, 11 minus 2. I think that's right. Isn't that right? 2 squared plus 5 equals 11 minus 2. Yeah, 11 minus 2. All right, so negative 3 squared is going to be 9 plus 5, which equals 11 plus 3. 2 squared is going to be 4 plus 5, which equals 11 minus 2. Well, 9 plus 5 is 14, which equals 11 plus 3, which is 14. And then 4 plus 5 is 9, which equals 11 minus 2, which is 9. So these check out. Okay? All right. What I want you to do for me tonight is I want you to verify C and D. Okay? This is your homework. I want you to verify these two. E and F we're going to do in class. So these are going to be classwork problems. Okay? All right, so exercise 3. Let's see. Okay, so we are going to work on solving these problems, but we're going to do, let me zoom in here. Okay. All right, so we need to work on solving for R. 3 divided by 2R equals 1/4, okay? If you know this from 7th grade, this looks exactly like a proportion. And if you remember, with proportions, you can cross multiply and divide. So cross multiply and divide. So 2R, so it would be 2R times 1 equals 3 times 4. 2R times 1 is going to be 2R, which equals 3 times 4, which is 12. Now, when you are solving equations, the goal is to maintain balance. Whatever you do to one side of an equation, you have to do on the other side of the equal sign. It's always got to be this way, okay? So now the question becomes, what is the opposite of multiplication, okay? Since we're trying to find R, we've got to get rid of this 2. So this is 2 times R, so the opposite of multiplication has got to be division. We've got to divide both sides by the 2. 2 divided by 2 is 1, which means R is by itself now. 12 divided by 2 is 6. Now we can verify this. We can verify that R equals 6 is our solution. We do 3 divided by 2 times 6 equals 1 divided by 4. Well, 2 times 6 is 12, so 3/12 equals 1 divided by 4. Well, 3 and 12 both can be divided by 3, so that does 3 divided by 3 is 1, 12 divided by 3 is 4, 1/4 does equal 1/4, so it checks. It's correct. Okay? So now we move on to B. By the way, C is going to be your homework tonight. I expect this to be done. All right, so solve for S. S squared plus 5 equals 30. So S squared plus 5 equals 30. The goal is to get this S by itself. So it means I have to do everything I can to get S alone. Well, I can't do anything yet because I still have this plus 5 here. All right, so the opposite of adding 5 is going to be subtracting 5. So I want to subtract 5 from both sides. Okay, this maintains balance. 5 minus 5 is 0. 30 minus 5 is 25. So now I have S squared equals 25. Now, we talked about this yesterday. When you get a square, you have to do what? Right. You have to do the square root of both sides. Okay? So now I have S squared, or the square root of S squared, equals, and if you remember when we're working with square roots, we have to do the plus minus because there are 2 possible solutions here. The square root of 25. The square root of S squared is S, and the square root of 25 is 5. So it's plus or minus 5. So the solution set for this one here, okay, if I was going to do the solution set, is a negative 5 and 5. That is my solution set. All right, I want you to do C for homework. Exercise 4 we're going to do in class, okay? So be prepared for that. All right, and last but not least, closing. All right, we are going to do this in class as our closing, so be prepared. All right, I do not want us to do that right now. It's a lot of work. Okay, so which of the following equations have the same solution set? Here's your homework, okay? I want you to do I, 1, 2, and 5. It's your homework. And I want you to practice solving. So I want you to do 2, 5, 8, and 4 for homework. Okay? That's going to be your homework tonight. All right, guys? Be prepared. we've got to hit and roll because we got a lot to catch up on. We are kind of a little behind. So be prepared. Please make sure you watch the videos, guys. Thank you so much. I love y'all. Y'all are the best. Y'all are amazing students. Don't ever forget that for me, okay? Oh, thank you all so much for being such awesome kids.